Bulletproof Radio, a state of high performance.
You're listening to Bulletproof Radio with Dave Asprey. Today's guest is Dr. Eric Kandel. He is a Nobel Prize-winning, renowned neuroscientist with a psychiatric background and truly one of the pioneers of modern brain science. He's been described by a colleague as one of the truly great intellects, one of the greatest scientists and greatest neuroscientists of the last 100 years, and something I would agree with. Dr. Kandel, my wife studied at the Karolinska Institute, where you gave an acceptance speech, and she was actually in the audience when you accepted it. And she asked me to tell you at the beginning of the interview that your medical textbook was her favorite book in all of medical school. And so she was really excited when she found out that we were going to get a chance to speak live. So truly an honor to have you on the show.
Well, I'm delighted to be here.
You recently wrote a book called The Disordered Mind: What Unusual Brains Tell Us About Ourselves. After decades and decades of research and looking at the mind, what do unusual brains what do they tell us about ourselves? Like what can we all learn from this? I've never had a chance to talk to someone who has this much knowledge in one brain and ask that one, what do we learn? The one point.
Well, we see what different regions of the brain do, what their function is, because we see that if some particular behavioral function is abnormal, we can trace it down to particular brain architecture. And that allows us to relate structure to function. There are a number of ways of doing it, but this is a very powerful way of doing that. What did the different brain regions and subregions mediate in terms of behavioral function?
Does this mean that if someone has a structural problem in their brain, that they're stuck? You know, you got hit in the head when you were a child. That part of your brain doesn't do what it was supposed to do. Is there hope?
If it's a child, yes. If, for example, you have damage to your left hemisphere, which is involved in speech, if that occurs to you as an adult, you have something which is very unlikely to return to you in its normal level of functioning. If this happens to you when you're less than, let's say, 12 years old, there's a very good chance that the right hemisphere will take over and compensate for it. So there's plasticity in the young brain that is lacking in your brain and mine.
Do you believe that we'll ever be able to turn on childlike neuroplasticity in adults?
Probably not.
Probably not. Okay. What drives that assessment?
Well, there are anatomical changes that occur in the brain as you mature that are almost impossible to reverse. So it's hard to consider that. Now, perhaps one can have a brain explant, that is to take some immature brains, perhaps from somebody else, and implant it in your brain. And that might get incorporated and function as a immature brain in your skull, underneath your skull. It's unlikely, but that's an outside possibility.
When we talk about unusual brains, it brings to mind a couple stories. I interviewed a woman who has a phenomenal brain for research and asked her, why can you do what you do? And she said, when I was 21, I had a virus in a part of my brain and it created a lesion that grew another part of my brain inside of it. And she says, ever since that happened, she could look at a stack of research papers and synthesize it in a way she never could before. So I always, like you, look at these outliers, or my wife. She hit her head when she was 8, before that 12-year-old thing, took out the language processing center of her brain. She fell off of a 2-story building and was unconscious for 3 days. She can do simultaneous translation and speak 5 languages and run an emergency room. But they now hypothesize, having looked at the structures in her brain, that it's because the right hemisphere took over. But she was a child example. The other one was an adult example. If you put on your 50-year in the future hat, do you see any hope for people being able to programmatically make those kinds of changes to our brains? Or do you think that's just too messy and it's unlikely we'll ever be able to do it?
it's hard to predict what's going to happen 50 years from now. It's hard enough to predict what's going to happen 10 years from now. I think it's unlikely.
Okay.
Also, to explant, to take a piece of brain from one person and put it into another person's head is not an easy game.
No.
And it's not the kind of thing you want to do routinely. You want to do it as an emergency measure. You don't want to do it as a way of enhancing your brain. Probably the more effective way of enhancing the brain is through practice, studying foreign language, the piano, the cello, etc., etc. That will cause enlargement of certain areas of the brain, give you new capabilities that you didn't have before, particularly if you start at a young age, where the brain is most plastic. You'll have the greatest chance of developing new capabilities that you didn't have before.
There are a variety of compounds that we've discovered that increase things like nerve growth factor or a brain-derived neurotrophic factor, BDNF. And it seems like we can raise levels of those by at least 50% in adults, even with things like exercise. In your experience in neuroscience, are those techniques likely to be valuable for helping adults learn better, or do you think those factors that's not enough?
I think it's unlikely that those factors will help adults, although it's certainly possible that we'll get some compounds, hormones, or substances that will enhance cognitive capabilities. The substances that you mentioned are those that are normally present in brain, and they're particularly helpful if some part of the brain is lesioned that produces that. So by giving it exogenously, you can compensate for the natural production of that by the brain.
Okay, that makes a lot of sense. I want to go back to 2 years before I was born, back to 1970, when you looked at how chemical signals change the structure of the connections between synapses. How did you arrive at the breakthrough to understand that? What was the learning process that led up to the aha moment for you? We're talking about the aplasia.
Between 1957 and 1960, I worked at the National Institute of Health. And I had earlier in medical school had a 6-month elective period in which I could do whatever I wanted to. And I wanted to be a psychoanalyst. And I thought that even a psychoanalyst should know something about the brain, perspective on the brain, and I just loved it. And based upon that one experience, I was nominated for the National Institute of Health. Why nominated? When I graduated from medical school, physicians were being drafted into the service for a 2-year stint. But those that were eligible were selected for a research program at the NIH. And I was selected for a research program at the NIH. And I enjoyed it so much I stayed not 2 years, but 3 years and had a wonderful experience there. And what I did there was to record from single cells in the hippocampus, the area of the brain that was known to be very importantly involved in memory storage. And I found how these cells worked, but I didn't learn that much about memory storage. And I realized that to study memory, particularly at the beginning, you needed to look at a behavior and see how it was modified by learning. And looking at the hippocampus was a little bit too complicated as the first step. So I decided to look for a simple system that had a simple reflex behavior that could be modified by learning. And I focused in on the marine snail aplasia because it has the largest nerve cells in the animal kingdom and relatively few of them. So you could work out a neural circuit, a withdrawal reflex, in terms of the individual cells that mediate it, work out the whole pattern of connections, and then modify that behavior with a simple learning process and see what happens in that neural circuit when the animal learns something. So for example, if I bang my hand on this table and I continue to do that, you will get bored, and after a while you will ignore that. That's called habituation. When you look at a neural circuit that mediates a simple behavior and you stimulate that reflex repeatedly, the reflex gets weaker and weaker. And when you look at the neural circuit, you find that the connections between the sensory neurons and the motor neurons are getting progressively weaker. So that was the first demonstration. The learning affects the strength of synaptic connections. If you scare the hell out of the animal, to startle, that same stimulus that produced a very weak reflex will produce a much larger reflex, much stronger reflex. That's called sensitization. When we look at what happens at the neural circuit, you see that the connection that was there to begin with and had a certain strength that weakened with habituation moved in the opposite direction with sensitization, became much, much stronger. So that was the first demonstration that learning involves the change in synaptic strength, how neurons communicate with each other. And that has turned out to be a general principle.
How could we take that new understanding of the brain and apply it to the things that we do as human beings?
You play tennis?
I play ping pong. It's pretty close.
Okay. When you practice ping pong, what do you think you're doing?
Pretty much changing synaptic strength.
You got it. When you continue to hit, you're getting, the reflex gets more and more effective, more efficient. A number of things go on. Your attentional system also improves, but you strengthen connections in order to do that.
Recently, the military's been using transcranial electrical stimulation to increase learning speed. In fact, I run an electrical current over my brain when I play ping pong sometimes using a device called a halo. Before that, I used an electrophoresis machine to do it. And in studies in the military, it seems to let people learn specialized skills about twice as fast. Do you think that's a dangerous thing or maybe a good thing?
I think you would have to not just stimulate the brain in a very general way. You'd have to stimulate specific areas.
Yeah.
I think, as long as it's done in a controlled fashion, a limited degree, it's an experiment.
It is.
In what circumstances it works and in what circumstances it doesn't work. What is the age range of people who benefit from this? So it's a new finding. It needs now to be explored in terms of safety and significance.
At this point, it definitely passed the FDA, and it's just running on the motor cortex regions. So for physical skills, and I think I see differences, but it's hard to also blind myself because you can feel it, and it's also hard to know. Sure. Maybe I would have learned that fast anyway without the electrical current. But
this is most likely to be most effective in people who have damage to the motor cortex for one reason or another, to allow them recoup their original function, to bring in other areas that compensate for the fact that the primary areas have been weakened by disease.
Okay. I'm also very interested in your work on nicotine. I interviewed a professor from Vanderbilt University who wrote the first paper in 1988 on using oral nicotine, not smoking, for treating Alzheimer's disease, and has been studying it for a long time. But I also know that you've looked at memory disorders, mental illness, and nicotine addiction, along with your wife, Denise. What's your take on nicotine after this research?
Well, nicotine acts on the brain and enhances the actions of certain drugs that you take after nicotine. So it has a powerful effect on the brain. Whether it's all beneficial is not at all clear. I don't think smoking is a particularly good idea, but smoking is more than nicotine.
Yeah.
It's also inhaling all the stuff that comes with the cigarette.
I would unequivocally say, having nowhere near your level of scientific credibility, but written some science books and looked at deep, smoking is just bad from an aging perspective.
Well, smoking is more than nicotine.
Much more, yeah.
It's inhaling all the stuff that comes with the lit cigarettes, yes.
And for nicotine itself, it seems like for some brains, there are very strong benefits, but for other brains, it just doesn't work, much like a lot of things.
Yes.
How would someone listening to the show go about knowing whether coffee, nicotine, egg yolks, or any other compound, fish oil, anything that may affect their brain, how would they go about knowing whether it works or not, given there's so much individual variability?
Well, the first thing is I would very carefully read the literature.
Yes.
To see whether you take a population of people, let's say 100 people, 1,000 people, and you expose you divide them into two groups, a control group and experimental group. You give a control group, seltzer, and you give the other group whatever the experimental drug is, and you see whether there's a difference between the two groups. And then you can statistically decide whether or not the drug that you're testing is beneficial and what it does that is beneficial for you. It may also be detrimental, or it may be beneficial, but it may carry some downsides with it. So it's very important to understand how a drug works in all of its ramifications before one approves it. That's why the FDA is there to evaluate the safety of these drugs.
It works really well for populations to do that. And when you have an individual looking at a drug like, say, modafinil, which is a well-known cognitive enhancer, in some people it doesn't do anything. In other people, it turns the lights on in a new way and changes their ability to think, even their typing speed. And I'm looking down the road and saying, if we know that there's this statistical curve of how it works across a population, do you think we're getting close to being able to tell genetically or environmentally or via some other mechanism whether a drug is going to work for one individual versus a broad population? Or do you think that's still far out in where we're going?
It depends on the drug. In certain drugs, you see that certain genetic predispositions allow the drug to work or prevent the drug from working. So there are some situations in which the biological information that we already have on that person or can easily obtain on that person will tell us whether this drug will be effective or ineffective in that particular individual.
I'm hopeful that companies like 23andMe and Ancestry.com that are now getting genetic information on hundreds of millions of people and starting to be able to do kind of the broadest epidemiological stuff possible to see not only does this drug work if you share that information with them, but it only works for people who have this whole genetic profile. And I've started to see some new information coming out of that. Do you think that approach is going to be adequate to at least peel back the onion on many drugs, or is it going to take more than that?
I think you really hit the nail right on the head. People differ from one another biologically, that is, to a large degree genetically. And if you look at any single drug in a population, there'll be variability in how effective the drug is. And knowing the genetic makeup of a person, and if you've tested that drug in a variety of different people with different genetic makeups, you can predict whether this is a good candidate for the drug or this person is a bad candidate. And that's important to know, because if a person has an illness that can be helped by the drug, he may be one of a number of people with that illness that will be helped, but there are other people who have other, biological predispositions who may not be helped. So the more we know about the biological underpinnings of a person, the more likely we are to make intelligent decisions about which kind of drugs will be helpful or which kind of disorders.
I'm exceptionally hopeful that this new data set is going to change our understanding of individual biological variants so that those unusual brains and unusual neurological structures and unusual genetic structures, it can be teased out, and we'll be able to go into a doctor and say, oh, why don't you try this set of compounds instead of this set?
Well, this is happening. We're beginning to get it just at an early stage.
Okay.
But physicians can tell from your biological history whether one kind of antihypertensive medication is more likely to be better for you or another. So in a number of disease states, there are several different drugs that will work, and which one may be determined by your biological makeup.
It seems like one of the most exciting times ever to be alive, given the amount of information that we have available as lay people and as researchers and physicians. How do you deal with, or maybe a better question is, how have you dealt with this amazing onslaught of information? If you go back to when you were working at the NIH in the 60s, you had a number of research papers, and you had connections with other researchers, and you'd have hallway conversations, and you'd go to symposiums. And now it seems like every day there's 100 papers that could be interesting to the things you care about. How do you decide what to look at?
These 100 papers relates to a universe of science. Let's say I'm a cardiologist. I'm interested in the biology that relates to the heart and to the circulation, etc. That's a more discrete number. And a number of those articles, I come up with findings that are modest. Others come up with findings that are wrong. And then finally, there are those that come up with findings that are correct and significant enough to make you rethink the kinds of therapeutic approaches you want to take to a patient with a certain kind of cardiac condition.
Okay, so you sort of sort the papers
exactly
based on what you're attempting to learn about or modify. That ties into something that you've said about reductionism. You once said it's better to make small progress on something really, really important than to push a trivial issue ahead. How do you think about reductionism, and how have you thought about it in your work?
I'm a reductionist. I try whenever possible to use a simple example of a larger problem and try to drive it into the ground. And then I come back and look at a more complex variant of that. But I like beginning on solid data.
How do you make that decision about what's really important versus trivial?
If you see a big change in a behavior, it's important. If you see a small change in a behavior, it could be trivial. I'm
okay. You're very results oriented. So the person who is psychotic isn't psychotic. Maybe we should pay attention there. And okay, that's a very pragmatic answer. How did it feel when you went through and you proved that Dr. Kuhal, a 1906 Nobel Prize winner, you proved that he was right in that he said he hypothesized that nerve cells talk to one another at the synapse. And when you had that proof point in your lab, what happened in your mind? Did you run around the street saying "Eureka," or did you celebrate with champagne? What was it like?
What I'm talking about is Ramoni Cajal. That's pronounced Cajal.
Cajal. I said it a little bit wrong. I said Kuhal. Cajal. Thank you.
And he was the first one to really pinpoint the fact that neurons communicate to each other at specialized junctions called synapses. And he also suggested that learning may involve alterations in the strength of these synaptic connections. I was one of the people who came along later on, substantially later on, and showed that his suggestion of how learning occurs is correct. I found that learning involves changes in the strength of synaptic connections. So Cajal was fantastically important, one of perhaps the most important father of neuroanatomy.
I want to know how you celebrated when you came to that full conclusion, when you saw the data on your lab bench and you said, wow, I've got really solid proof of this. Now we know. Did you go home with Denise and have a dinner? Like what do you do when you just realize you've proven a major point that's world changing?
The first thing you ask yourself is, what are the controls I have to run in order to convince myself that this is so? But some skeptic like you won't say this is complete baloney. So you want to think of the controls that you need to run. But of course, one goes home and one enjoys oneself. It is a wonderful thing. And also, to have it being recognized generally, the paper being recognized as an important paper, is very satisfying that your colleagues think it's important.
So you do celebrate.
Oh, of course.
So how does a Nobel Prize winner celebrate? I want to know.
Champagne.
Champagne, all right. The real French stuff, right? All right.
Get me out of these wet clothes into a dry martini is what the golfers used to say.
I love it. All right. Let's talk about memory. Your memory is exceptionally sharp. You're going to be celebrating your 89th birthday about when the podcast hits the air. My birthday is a few days after yours, so happy birthday in advance.
Thank you.
What have you done to keep your memory, both short-term and long-term, working as well as it does?
I don't do anything specific about it, but, I read, I write, I talk to people. I don't go home and memorize poetry, but I stay intellectually involved. Many people my age have retired, no longer involved. I'm talking to you from my lab. This is my office. Research is going on just on the other side of the wall here. And I'm involved I don't work every day. I only work about 5.5 days a week. But when I'm here, I'm intellectually involved in what goes on in science. And that stimulates the brain. Also, I mean, when I'm out of the lab, I also stimulate the brain. I go to the opera. I mean, I do things that almost everything you and I do during the course of the day involves intellectual activity of one kind or another.
So continuing to exercise your brain by using it, it keeps it younger,
That's
or at least running. Okay.
Yes.
Can you talk about self-perpetuating memories and what you've discovered about those?
By self-perpetuating, you mean what?
A self-perpetuating protein at the synapse, and that if memories are sustained for a long period of time, what changes versus things you memorize a phone number, you dial it and you forget it?
There are mechanisms at the synapse that once you produce a change in synaptic strength, you produce an alteration in the local machinery for protein synthesis that keeps the process going. So there's an alteration in gene expression that gets transported down to the synapse and that allows the synapse to produce more proteins or more substances that are necessary to strengthen that synapse.
What happens if you're remembering something traumatic versus pleasurable?
Well, they both produce alterations in synaptic strength, but they produce it in different systems. There are some systems that mediate pleasure, some systems that mediate pain. So you recruit different anatomical pathways to mediate one versus the other.
Do you support the concept of PTSD, the post-traumatic stress disorder?
Absolutely.
I was hoping you would say that. Certainly something that I've experienced.
I'm at a table and scare you. I can tap lightly the next time and you'll startle. So there's no question this is true for all of us. We have different thresholds. Some people are much more sensitive to it. Also, once you've been really frightened, you're much more susceptible to less threatening stimuli.
Do you think that's something that we can change?
No. I mean, I think that's built into us, and it's probably beneficial. We want to be able to startle. We want to be able to move away from stimuli that are dangerous. But we should be able to get progressively better ways of helping people overcome the excessive fear that they show on a variety of circumstances. So, for example, if somebody is at a war front and sees a bomb explode nearby and hears this terrible noise that's associated with it, they may be frightened every time they hear even a slight noise. That sort of post-traumatic stress disorder, one should be able to get them over it, if only by habituating to them. Play that sound in a way that is clearly innocuous and convince the person's nervous system that no damage is going to occur.
Is there a way to look at the way we lay down pleasurable memories and use that kind of that system in order to get it active when people are re-experiencing those sounds? And in others, is there a way to turn the brain onto pleasure mode versus fear mode?
Not so very easily.
Why do we remember things from childhood, like a song that sticks in your head from childhood, and other things like high school algebra just go away? What's going on with the way we store and sort information like that?
Well, I mean, some things are more satisfying and more meaningful to us than others. And probably some things, your mother's love or the first girl that you met and you really liked, that's more important to you than high school algebra.
So it's a measure of importance.
And satisfaction.
Do we have any other control over how our memories are stored?
Yes, repetition.
Repetition. Okay.
If you want to learn French, you can't have one conversation in French and expect to master the language. You have to go and learn it. And one way you learn it is, learning the grammar, repeating things, practicing, speaking it, et cetera, et cetera, et cetera. Practice makes perfect is one component of learning.
I have found that for me to really learn something at the deepest level, I either have to teach it and I was a teacher at the University of California for about 5 years, or I have to write a book about it. What is it about teaching or the act of synthesizing to write that makes things stay in your brain?
Well, you've described it perfectly. If you really take it apart, so you understand the component parts and how they fit together, so that you can explain it to your grandchild, it's going to stick in your head as well as making it easy for the grandchild to understand it. So taking a complex piece of information and simplifying it, thinking it through, is a very, very good way of learning it so you can hold on to it for a long period of time.
Is there a better way to do that?
Well, repetition is very good.
So it's either repetition or...
Understanding is important. If you don't understand it, it's very hard to remember it.
Got it. So it's either repetition or disassembly and reassembly in a new way are the two big techniques.
It's sort of related, yes.
Okay. In your newest book, you talk about something you could call a unified theory of the mind. How would you explain the one theory of the mind around how our sense of self emerges from physical matter?
Well, people used to think that brain and mind are separate, that the brain mediates walking or running, motor activities, but mind, understanding something, communicating with something else, is not mediated by the brain. Now we know that every mental process is a biological process that comes from the brain. Simple or complex, trivial and sublime, they're all brain processes. Every mental process is a brain process. That's been a major advance of the last 50 years.
Have you dug in on the role of mitochondria in the mind or in the brain?
I mean, I obviously know that mitochondria, source of energy in cells, are important, particularly at synapses. But I haven't worked on mitochondria in any particular way.
Okay, you haven't worked them in a particular way. Because I know that in your book on disordered things, you talk about autism and depression and schizophrenia and Parkinson's and addiction. And there are clear mitochondrial links to those things. And the neurons have more mitochondria. And I've spent a lot of time on my last book looking at how do mitochondria behave that affects how neurons behave. And it seems like if there's not enough electricity being made by a mitochondria, you wouldn't get enough synaptic firing, and that may be an important part, at least in some conditions. Knowing that you're not a mitochondria expert, does that theory hold water? Given that you know way more about the brain than I probably ever will, is that an area worthy of exploration?
Not sure I know more about mitochondria than you ever will. I would have to read up on that. At the moment, I'm not convinced.
Okay,
but
is it at least worthy of asking?
Absolutely.
Okay.
Absolutely.
Good deal.
Very important.
Okay.
But we don't know all the roles they have in learning and memory.
We absolutely don't. In fact, I think we don't know. We don't know very much about them at all right now. I want to go back to short-term memories. What's the difference between that example of remembering a phone number? What happens in your synapses, something that you know you're only going to need for a little while versus something that gets embedded in your brain? I know we talked about repetition, but what's happening at a synaptic level when you just want to remember it for a little while?
There's a short-term change in synaptic strength. When you learn something for short-term memory that persists for minutes, the synapse changes, but it's a functional change and it only lasts for minutes. But if you learn something through repetition, or because it's very powerful for you, you actually see an anatomical change occur at the synapse. The synapse becomes anatomically more powerful, and that's reflected in its physiology also. The presynaptic terminal is larger, the postsynaptic contact point is larger, so the synapse is much more effective because it's anatomically more effective. Fundamental differences between short-term memory and long-term memory. Short-term memory involves a functional change at the synapse. Long-term memory involves an anatomical change. Moreover, that anatomical change is produced by alterations in gene expression. So a signal gets sent from the synapse to the nucleus. New gene products are produced, transported out to the synapse, and that allows the growth of new synaptic connections.
Is there something we can do to increase meaning consciously to make it easier to remember those short-term things and make them longer term?
Repetition, my boy, repetition. Practice makes perfect.
I'm feeling good that you've told me that 5 times. So by repeating it for me, then I'll be able to remember it.
Help you. Shoot you for the therapy session.
Let's talk about exercise.
Excellent.
We know that exercise is good for the brain at this point. And when the New York Times was interviewing you, I think last year, you said you've exercised your whole life. Now, there weren't a lot of people who practiced exercise in the 50s and 60s, but you did. What made you decide to do that?
I'm embarrassed to tell you this. First of all, I was in Vienna, 1938, when Hitler marched in. And one sport that Jewish boys in Vienna learned after Hitler marched in was to run away. So I was surprisingly fast. When I came to the United States, I tried out for my high school track team at Erasmus Hall High School, and I was co-captain of my track team in my senior year. In fact, it was the coach of the track team who asked me, Eric, where are you applying to college? And I said, I'm applying to Brooklyn College. My brother's going there. It's a very good school. And he said, have you ever thought of Harvard? I said, no. He said, why don't you apply to Harvard? So I applied to Harvard, and I got in. And that was due to my track coach pushing me. Not that I was a great track star at Harvard. I was not. I was not good enough to really compete strongly at that level. But I was quite good in high school. I placed in the city championship, and I ran on a relay team with 3 other people. So a relay team is 4 people. And we won in all sorts of major events. The Penn relays, the Seton Hall relays, etc. So
you learned in high school that it felt good, and you just kept doing it ever since.
Right. Well, I became very athletically involved. In high school, I was almost crazy in the amount of time I spent practicing for running. I had a co-captain of the team with me was a guy called Ronald Berman, who also was my roommate at Harvard. We went to Harvard together. He was better than I was. But together, in high school, we took track very seriously. And even on the weekend, when there was no school, we would go running. We'd find a track and we'd go running there. We'd work out.
Did you ever start smoking?
I smoked for a while. Let's say between 25 and 27, I smoked.
Just for a couple of years. It's unusual to quit, especially given how common smoking was at that time in society. What led you to quit?
I knew it was bad for me, and I guess I didn't enjoy it all that much. I didn't become addicted to it very badly. And my wife, Denise, didn't like it very much.
That's a good way to quit an addiction when your wife doesn't like it. So the next book I'm working on is around anti-aging. I've spent 20 years running a nonprofit in this space. And
I'm working on that also.
You're doing something right with anti-aging.
It's old. I'm working on anti-aging. And I found the cure.
What is it?
The cure is walking.
Oh, I love that answer. Tell me more.
Cure is walking. So there's a guy called Gerard Kasecki, was one of several at Columbia, one of several people that showed that bone is an endocrine gland, mm-hmm. and it releases a hormone called osteocalcin. And I've been interested in whether or not osteocalcin is enhanced, release is enhanced when you walk, and the answer is it is. I found that one way of overcoming age-related memory loss, which is a significant problem, is by walking. So I used to swim most days, and I've now substituted walking for swimming. I walk to work and I walk from work, and I have a rucksack rather than my briefcase, because when you walk a significant difference, a briefcase is asymmetrical. Yes. You carry it with one hand, while a rucksack is on your back and, gives you greater freedom.
Yeah, and you get more even loading on the spine. And over the course of walking for 20 years, you don't want to be crooked on one side. Okay, that makes great sense. In the research that I found for my last book on mitochondria. It turns out 20 minutes of walking a day is enough to cause mitogenesis and to keep your mitochondria young and strong. So there's
Wonderful.
something there.
Dependent support.
I also use a machine. I have a lab here at my house around longevity and recovering faster than Mother Nature maybe wanted you to. And the machine allows you to, under your own power, flex your bones and keep them flexed for 5 seconds.
Sounds very good.
It's probably raising osteocalcin, and we certainly know it stops osteoporosis in most people, even cervical osteoporosis. And I feel like there's all these new things around the effect of certain frequencies of light on tissue healing, on collagen synthesis, and all of these new discoveries that are coming from all sorts of different disciplines that end up taking different biological systems in the body and keeping them younger. Do you do anything like that as part of your anti-aging, aside from walking and I'm assuming eating a reasonably healthy diet and not overindulging on champagne? Are you doing unusual things?
No.
Nope.
I walk. I like to swim. For example, when Denise and I travel, I always insist that the hotel we check into has a good pool. And, around home, there are a number of pools that I can use. And those are the major exercises I get. I mean, we have a trainer coming once a week and we do push-ups and things like this.
Okay. Well, you're doing very well. Having worked with a variety of people over age 70, your memory seems like it's completely sharp and you're recovering things from high school at will. And that's highly unusual. Do you think you're genetically gifted in that way, or is this just the way you've lived your life?
Not at all.
Not at all. All right. If you look at someone who's, say, 20 years old today, who has the benefit of your work and hundreds of thousands of other people around the world, how long do you think they might be able to keep their memory intact, or even how long do you think they might be able to live?
Well, certainly as a result of the improvement in medical care, as a result of the improvement in how we attend to our body in order to keep ourselves as physically healthy as possible. And as a result of the study of the effects of alcohol and smoking, et cetera, a number of things that easily become dangerous rather than being beneficial. We now have a reasonable idea of what kinds of things are good for us and what kinds of things are not good for us. And a combination of a good diet, a good physical activity, and a minimum amount of alcohol and no smoking if at all possible gives us the beginning of a formula for a reasonably healthy life.
When you look at how the world's changed over the last almost 9 decades of your life, do you have any thoughts about how the world's going to change over the next 9 decades? You have the benefit of having seen way more history than I've seen. You have wisdom that I may have when I'm 90. How do you put on your futurist hat and say, wow, here's where I think things are going? Do you spend time on that? Do you have theories about it, ones that aren't proven yet?
I have a difficult enough time living in the present. So I don't know that much about what's coming in the future. I clearly see that, for example, in medicine, there are many problems that we're beginning to understand, and that we're beginning to treat, and that will get better and better. For example, coronary artery disease. We know that diet is very important for that. We know hypertension has to be controlled in order to minimize cardiac damage, et cetera, et cetera. So we've learned a lot of hygienic rules that improve the physical quality of our life. And they're very important, and they're not that difficult to follow. The trouble is that people become addicted to certain patterns. They become addicted to smoking. They become addicted not to 1 or 2 glasses of wine an evening, but to several glasses of wine followed by several glasses of scotch, whatever, beginning with scotch and then going to wine, whatever the sequence is. So I think one has to be reasonable about what one takes in. I think diet is very, very important.
So for someone who starts now when they're 20, if they take advantage of what we know about walking and food, they have a much better chance when they're 90 of having a highly functioning brain.
Absolutely. Absolutely. Also, watch your weight.
Yeah.
Obesity is a terribly detrimental thing.
I weighed 300 pounds when I was about 23.
Wow.
And I'm 9.6% body fat right now. And it took me years to figure out all the stuff that was going on. But
It's terrific that you did. You look terrific now.
I would have to just double down on what you said there. That being obese is really not good for you, including for your brain.
Absolutely not.
Is there a field of medicine, knowing all what you know now, that if you were to start over, that you would go into? Like if you were just entering medical school now, what would you pay the most attention to?
I don't know. I still like psychiatry.
Yeah.
Which is what I was trained in. It was a primitive discipline when I entered it. It's a primitive discipline now, but it's making progress. We're beginning to understand the brain better and better. We're beginning to relate different mental illnesses to different parts of the brain. And although we have not made tremendous therapeutic progress in the last 20 years, if you look over a period of 40 years, we have made significant progress. I think that will continue to come. It's an area in which much growth is likely to occur.
So even if you were starting your career again today, you would still go into psychiatry?
Psychiatry, yes. I also like one aspect of psychiatry. An important part of psychiatry is psychotherapy, if you will. Mm-hmm. Being comfortable with patients, their good behavior, their bad behavior, their painful behavior, and not only being empathic, but expressing instinctively your empathic response to them. So you just have to enjoy being with people. And I like that part of it a great deal.
You still write an enormous number of books. You have a long string of highly successful books that have won the highest literary awards. How do you sit down when it's time to write a book? How do you know when it's time? How do you go about doing it? Do you stay up late typing? What's your ritual for writing?
How do I know what I think unless I read what I write? I'm serious.
Okay.
I write with pencil and paper.
Okay.
I don't type. I mean, I can type very badly, but I don't type it out. I write it out, and I have a secretary who types it out for me. She's very gracious and reads my handwriting pretty well. And I do many drafts, but I enjoy writing a great deal. I get enormous pleasure out of it. I can write on planes when I'm traveling. I write in the evening at home, after dinner, on the weekends. And I really get a lot of pleasure out of doing that.
Are you working on a new book now?
At the moment, I'm not working on a new book, no.
Do you still read fiction?
Not very much.
Not very much.
It's a shame, but I don't, yes.
Do you have a favorite fiction book from your life that made a big difference for you?
Moby Dick.
Moby Dick.
That made a big difference for me.
What difference did it make?
Well, it's such a fantastic story of seeing this whole animal life evolve. It really provided biology and fiction in the same context.
Got it. It's always interesting to hear what someone who creates work goes to for inspiration, and what a fantastic just perspective on it. I love the infusing of biology and fiction. When you do sit down to write your next book on paper, do you form the outline and fill it in, or do you just let it flow from your brain and then redraft it?
I usually have an outline of something, a chapter, a couple of chapters or something like that. And I sit down and I just scribble it out. I just, I don't pay much attention to the detail of the form. I mean, I'll cross things out and correct them. But I consider the first draft just a beginning, get me going. And then my secretary types it up for me. And then I play with it and amend what I've written and expand.
Well, your process definitely seems to be working, because you're prolific as a writer in addition to as a scientist, and that's something that I know I can learn from. So thank you for sharing your secrets.
And you raise a very, very good point. one of the things that I find, to my surprise, that distinguishes me from my colleagues, who are every bit as good as I am in science, is that I communicate better with the public, in part because I write, but also I was on the Charlie Rose program. I've been in a number of television programs that are designed to allow scientists to speak in straightforward language to the general public. And I've always enjoyed doing that.
Do you think that's because of the time you spent studying psychiatry and spending time, quote, on a couch or at least with a patient on a couch?
No. I think it's due to the fact that in my early years, in addition to being a competent scientist, I was also recognized as a very good teacher. So I was recruited to NYU to develop the neuroscience program there. And then Columbia stole me from NYU to develop the neuroscience program there. And I worked terribly hard to develop those programs. I would, in a medical school, in a neuroscience course, I'm making up the number. Let's say there are 40 lectures. No person gives 40 lectures. So one person might give 8 lectures, 10 lectures. And then you have a number of people who give 5 lectures, some people who only give 2 lectures. And what I would do is I would not only rehearse my own lectures, I would rehearse the whole course. Sit there and I listened to other people's lectures, and they saw that I did this, and that they started to do this for themselves. And I always, my early years, if I was, going to Chicago to give a lecture, I would rehearse it. And I would encourage my colleagues to do the same thing. So that really helped me in understanding when am I getting across and when am I confusing people. And that's very helpful.
So you practiced being a teacher and becoming an excellent teacher, and then you took that into your writing.
Very well said.
That is beautiful and inspiring for me. Thank you. Dr. Kandel, I have one more question for you in our interview. If someone came to you tomorrow and said, based on your life's experience, including your work, but not just your work, everything you've lived through in almost 89 years, I'd like your advice. I want to perform better at everything I do as a human being, which includes, relationships, living, being happy, career, all the stuff. 3 most important pieces of wisdom or advice that you would offer to someone, say, who was 20 or 25. What would you offer? Just 3.
A good marriage is a marvelous, marvelous bedrock on which to live one's life. You have not only a lover, but a best friend whom you can really rely on under all circumstances to tell you that's bullshit and this is not. And that's so helpful to have.
Yeah.
No axes to grind. Not infrequently when we go out in the evening, I turn to Denise and say, does this look all right? Blah, 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 blah. It's wonderful to have a person who's concerned about you from a different point of view than you're concerned about yourself, as an objective perspective. And a good marriage is just a wonderful thing.
So that's 1. So definitely have a good marriage. You get 2 more.
A good career is not a bad idea.
Okay.
Something that you really, really enjoy. And knock yourself out to do something original in it. And 3rd, stay physically active.
Stay physically active. Beautiful pieces of advice. And thank you so much. It's been a great honor to be able to interview you and to learn from your life's wisdom in addition to all of the amazing neuroscience that you've done in your career. Thank you again for being on Bulletproof Radio, Dr. Kandel.
I really enjoyed discussing things with you.
Well, we got the show. Would you? I normally recommend to people at the end of the show that they read something or look at something from the guest to learn more. You have done so many great things that I'm not sure where I should send people. Should I ask them to read your most recent book? Would that be helpful?
So I've written 4 books for the general public. I think the one that is probably the most interesting for the general public is called In Search of Memory. The Emergence of a New Science of Mind. The New York Times Book Review said, a scrupulously detailed yet magnificently panoramic autobiography. I didn't write that. Sometimes I wrote that. Arresting and indeed unforgettable. An enchanting book. So nice things were said about it. Then I wrote 3 other books. I think that's the best book.
That's the best book? All right.
Yes, in terms of a general introduction to my work. And that's the first of the 4. The next book I wrote was called The Age of Insight, The Quest to Understand the Unconscious in Art, Mind, and Brain, from Vienna 1900 to the present.
Okay.
And that takes my interest in Klimt, Kokoschka, and Schiele, Viennese artists, that's where I come from, and brings my interest in art up to date.
All right.
A third book I wrote is, I'm interested in pointing out how the arts and the sciences are not 2 worlds apart, but often artists use the same kind of strategies that scientists use in order to solve their problem. They use reductionist strategies. So they may paint in very simple ways. Take a Rothko like this, for example. What could be more reductionist than this?
Right.
All it does is put, bands of color on it. But if you sit in front of one of these paintings, it's like a religious experience, because each one of those bands of color is in fact several layers on top of each other. So you can see the deeper layers coming through. It's really a almost religious experience. It's wonderful.
I love that you wrote a book on art and brain science.
Yes.
It seems like sometimes in the quest for reductionism and Western science, the role of art gets lost. And here you are.
So marvelous. And it's if you go to my house, you would have such a good time. Even my office, I have art hanging on the wall here. Denise and I just love to be surrounded by art. On the weekends, we usually at least hit one museum or something like that.
That is so beautiful. If you liked today's show, I highly encourage you to read some of Dr. Kandel's books. And any of these books will be illuminating, and it's rare to be able to get inside the mind of one of the great leaders of science and see how he thinks, how he evolved, and even how he thinks the brain and art interact. So if you like reading or you like listening, I highly recommend Dr. Kandel's books.